Okay, ellipses. We're in 10-4. We're going to take this slow. I'm going to give you a lot of vocab this time. And then we'll do part of the homework assignment. And then on Wednesday, we'll wrap up ellipses. So I know it's more challenging when we're far away from each other like this. So we'll take it a little bit at a time. So an ellipse is the set of all points and in a plane such that the sum of the distances from two fixed points is constant. All right, so we need two fixed points. So if I put a point here and a point here, and we're going to find a distance from this point and a distance from this point, and we're going to add those two distances together. So let's say we go here and we go here. So there's our fixed point. And then that sum, or those two distances added together, will be the same as that distance plus that distance. They'll be the same value. And that distance plus that distance. So you're going to get a set of values, or a set of points rather, that the values of the distances from those 2 points will be exactly the same. So let me draw it a little bit better. There's our 2 points. And an ellipse looks like an egg. So all of those points along here, their distances from these fixed points, the sum of both of them is the same. Let's throw some axes on here so we have a nice point of reference. These 2 points are called the foci. So foci is plural for focus. Foci. There's one there, and there's one over here. There's also a vertex on either end. So vertex or vertices is plural. Vertex, vertex. All right, we also have another vertex here, but it's going to be called the co-vertex or the co-vertices. They're on a shorter axis here. So foci, vertices, co-vertices. All right, I'm going to draw my picture again, and I'm going to add some other things to it, trying to keep it not too terribly cluttered. All right, we still have our foci and our vertices. The axis that the foci and the vertices lie on is called the major axis. It's the longest axis. And then the axis that the co-vertices lie on is the minor axis. All that to say, we can have an ellipse that runs this direction too. So our foci and our vertices are actually along the y, in the y orientation here. They're in the x orientation here. So this would be the major axis, this would be the minor axis, whereas in this ellipse, the x here is the major, the y is the minor. So you just have to make sure you know which orientation the ellipse is facing in. Okay, there are some distances in here. We are concerned about the distance from the center of the ellipse out to the vertex, or a vertex, and we're going to call that distance A. The distance from the center to the focus, we'll call that distance C. And then the distance from the center to the co-vertex, that distance is B. So you have an A, a B, and a C. And there is a relationship between these three. If you reoriented these, you would have a lovely right triangle. Guess which of these three values would have to be your hypotenuse of your right triangle? The longest. So if you have a right triangle, you may use the Pythagorean theorem to help see the relationship between the sides. So there is a Pythagorean relationship between A, B, and C. So A squared is the hypotenuse equals B squared plus C squared. That's the relationship of those three measurements in an ellipse. Okay, so let's talk about the equation of an ellipse. The equation of an ellipse. It looks a lot like a circle in that you can find your h and your k. So we're going to have x squared over a squared plus y squared over b squared equals 1. Your h and your k will be in here, so you can have an x minus h squared over a squared plus y minus b quantity squared over b squared. Pardon me, y minus k over b squared equals 1. So this would show where the center of the ellipse is located at h, k. Let's stick to a simple one. Let's write an equation for an ellipse. And let's say that the given information is A equals 5 and B equals 3. So it would look something like, if the center was here, we would have A equals 5. So from the center to the vertex would be 5 units, and from the center to the focus would be 3 units. Now this doesn't tell you what the orientation is, right? You would actually have to see the ellipse. So let's say the ellipse looks like this. And so we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3. So let's say this is what the ellipse looks like. How then would you write your equation? The center is at 0, 0. A is 5, B is 3. So let's take a look. Our major axis happens to be the y direction this time. So we would have A would go with the y. B, since that's the minor axis distance, that goes with x. So we can write it as either y squared over 25 plus x squared over 9 equals 1. Or since the addition property is commutative, you can write it as x squared over 9 plus y squared over 25 equals 1. So that's how that works. You needed the picture, but you also needed to know your A and your B. All right, let's do one more. Let's write an equation for an ellipse with vertices at 6, -8 and 6, 4, and co-vertices at 3, -2 and 9, -2. Okay, I'm going to pull out my graphing paper here, and this will be helpful, I think. So at 6, -8, so over 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, and 6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So these are vertices. I'm going to put a little v next to them just to remind me that they're vertices. And then co-vertices at 3, 1, 2, 3, negative 1, 2, and 9, negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 2. So my ellipse looks something like this. So again, we have another y-axis oriented ellipse. But the center is not at the origin. Now we've got to figure out where the center is located. Well, that's silly. It's halfway, right? So halfway in between would be right there. So what is the coordinate for the center? 1, 2, 3, 4, 5, 6, down 2. So that is 6, negative 2 is my center. Okay, center is at 6, negative 2. All right, so we can also do this will be y minus negative 2 quantity squared plus x minus 6 quantity squared. Now we need to figure out our a and our b. A is the distance to the vertex, so let's count that up. 1, 2, 3, 4, 5, 6. So a equals 6. And the distance to the co-vertex, 1, 2, 3, is 3. So b equals 3. So make sure you put these under the right variable. We are y-oriented. It's the long way. So a, 36, it's a squared, goes under the y. And b squared, 9, goes under the x, equals 1. There you go. Not too bad. Give a try a couple of your own.